Great. Well, this week was sort of interesting, I thought, because we hear a lot about learning styles. That's pretty prevalent, and a lot of people think they know a lot about learning styles as well. So just digging into what some different aspects of that were, I thought was pretty interesting. Did any of you guys had a reaction to that in terms of, did you already know about most of the learning style myths, if you will, or not, or do you disagree with that, or do you agree with that, or what are some reactions?
Just in case someone hasn't read it, would someone be willing to summarize some of the
very thoughtful
information?
To have that.
Very thoughtful of you.
My friend is asking.
You're asking for a friend.
So
what happened in the chapter?
Learning styles are not particularly well supported by scientific evidence, is the claim in Make It Stick. And I will also say that if you take PFF Part 2, you will not hear anyone telling you good things about learning styles. In fact, Jared Danielson will come and tell you bad things about learning styles. So I'm fairly convinced at this point that I should listen to the science people and not the learning styles people.
What do they define as a
Learning styles?
There's like 80 different definitions.
Sure.
Well, so what they were doing particularly is they were digging into the idea of like visual learners, kinesthetic learners, and they're saying these things may be beneficial, but there's no evidence that they are more effective than other methods that we have of increasing learning. So essentially, there's no evidence, at least at the time of this book.
Well, and
being written.
I forget the department's name, but anyway, Jared Danielson is like a tenured person here in some department who does PBL stuff. Anyway, he will go further and say, for example, that one survey of learning style stuff actually was like, let's test it. Because why not? That's like the least you can do. And so they just did like a one-axis test of, okay, we have these people who are supposed to be visual learners and these people who are supposed to be auditory learners. So let's have people from each group do each of those things and see how well they do on the exam. And everyone did better with the visual stuff, but the people who were identified as auditory learners did even better than the people who were identified as visual learners on the visual stuff. Mm-hmm. So it was negatively correlated to what the learning styles claim was in the first place.
So is the claim that they're, so I'm gonna guess maybe change this into three things. Is the claim that people do not learn in different ways, or that there is not a good way to categorize how people learn differently, or that there is no positive reason to teach differently based on some kind of categorization of the way people learn? Like, what was the argument?
Definitely not the third thing. I will tell you that.
Okay.
So I think their point was that we have certain ways which we prefer to learn, but those might not be the ways that we learn best. So we have to be very careful about aligning those different things in our perception of how we're learning or not learning. And the idea is they actually moved it into a discussion of multiple intelligences, which they were saying was somewhat evidence-based, and the idea of more, how can we think of this in I have weaknesses in more of a formative way, in terms of I have weaknesses in this area, and this area, and this area. How can I work to make it better? As opposed to sort of what they wanted to avoid was the pitfall of I am this type of learner. So if it's not that way, I can't learn that way. If anybody else has something.
They also talked a little briefly about the subject also, it depends on the subject too. Like certain types of visual learning is going to be better for, I think they use geometry as an example. And then
Poetry
was auditory, right? So
both, yeah.
Yeah.
I thought that was interesting.
So what you're learning also has a factor in the way you should be learning. We didn't talk about that for very long though, but it stood out to me.
I think the quote, even at 3, sort of brings out the point they're trying to get, which says, the theory holds that people who receive instruction in a manner that is not matched to their learning style are at a disadvantage for learning. I think that's the statement that they were trying to show is not supported
Gotcha.
with evidence there. So it's interesting. I was wondering then, bringing into, I've definitely had students tell me that, I learn in this particular way and that's not matching what you're doing in the classroom. So I was wondering if you guys had any thoughts or ideas on how we can address this, a bit of this disconnect of helping students who have identified themselves as a certain type of learner and seem to truly believe that they're not able to learn as well in other ways. Or if you guys had experienced that, or I've had students tell me that I learn, like I'm a visual learner before. Have you had students tell you that they're a different type of learner, or what are some of the things you've heard?
The most common one as a CalTA is I need to see lots of examples.
Examples.
Yeah, I
Learn
was
by
just
doing
gonna say that.
examples.
Which ties into later stuff from this.
I hear visual a lot, but to me that's usually just a cue of like, I'm having trouble picturing this on my own. Like, I really need you as an instructor to like kind of help me construct maybe like what's going on.
Yes.
And so I think sometimes people will just say like, oh, I'm a visual learner and that's why I'm not getting it. Like, I need someone to kind of help me draw a picture. Or like, oh, I'm an auditory, like learner. I do well with like talking to someone about the subject, and so I think it's kind of like they're kind of like feeling like where are they like missing or where they feel like they're kind of like missing material.
Got it.
And they're just kind of like noting that.
Using that label for that.
Yeah.
Well, I think that's very true.
I've heard a lot of students also say, well, I'm a visual learner, and so therefore I can't read the textbook. The textbook makes no sense to me. And I can't learn mathematics by reading it. And
The textbook has a lot of
The
cool
textbook's just
pictures and-
hard to like read though.
I
It's
would
just like,
I would
yeah.
agree with that. But I think going back to earlier chapters about the effortful learning, if they broke down the statements, I think they would realize that they could learn quite a bit by going through the textbook line by line. But I agree completely. I mean, we're talking about novices who are.
I think they expect to read it like you read an English essay, where you read it fluidly, whereas when you read math, you read it very slow,
Right.
and they probably haven't been taught how to read mathematics.
Right.
I think a lot of times from students you either hear that like I'm a X type of learner in a kind of either a sort of defeatist type of way, like, oh, I can't do this because of these limitations that I have, which is not super helpful. But also, like kind of what Kate was saying, you sometimes have students who feel like this is the people who are invested in their own learning and want some kind of change based on, like, this is the way that I learn, can we try this other thing? Which is always super helpful to hear that sort of thing from students.
I thought the reading was really interesting too. This maybe isn't central to the chapter, but it really stuck out to me on number 5 here. So they were talking about differences that do matter for learning. If learning style is less important, what are some of the things that are more important? And it says, on any list of differences that matter most for learning, the level of language fluency and reading ability will be at or near the top. So that ties directly to me into the idea of, reading a word problem, reading a textbook, etc. It's a different kind of reading than English, reading an essay or so on, but it's still that idea of reading comprehension and can you take words and bring sense into it. And I was thinking, students can come in with very poor reading comprehension abilities, and we can't do anything about their background. We can't change their background, but what can we do to help students improve?
Well, one thing that we cannot do or can avoid doing is like coming up with too cute problems that make it harder and increase the baseline from where it could be. I mean, this is a real thing that someone was, I forget who it was, let's pretend I'm forgetting for FERPA reasons, but a graduate student had a student in Calc 1 or something, either this semester or last, and on one of the exams, like, Steve Butler had this problem that involved, like, some kind of, like, it was very whimsical and had, like, this like, fun story at the top of it, but it was like, yeah, like Dr. Seussy language, and, like, this student complained to their TA that, like, cool, this isn't my first language, I didn't understand a single word of any of this, and, like, I'm inclined to agree with that student. Because it's yeah, I like the way in our projects that there is some distance between the fun stuff and where the stuff you need to know for the problem actually is, for example.
Some visual difference there. So how do you think we can help students get better at reading problems better, or the textbook? I know that, for instance, many teachers do, and I know in TBL there are some reading guides available, which seems like a very natural way of helping students digest. But frankly, you know, if they're, say, even in TBL reading guides and videos, a lot of students may choose to watch the video if they don't feel like they are able to access the text. So it's probably the students who need to read it, learn how to improve their reading comprehension the most, that don't choose to do that. And I was just thinking, I don't have any answer I'm looking for here.
I think Pathways to Calculus does some of that. Like, that's like our first, like, you know, it's like our first, like, unit, or first, like, third of the class.
Okay.
Is very much focused on, like, you know, it's just because all of the questions are, like, they describe, like, a situation, and there's, like, people walking places, and a lot of it just kind of comes down to, like, can you, like, draw out a diagram? Can you write equations for people's distances, you know, from, like, all of these different parts?
Yes.
And just kind of, I think, slowing that down. I think, just the students think it's all, like, goofy, and they're like, this makes a lot of sense. And they're like, okay, like, let's all do this now all at one time, you know, and they kind of like, I don't know where to start. It's like, okay, you do know where to start, you know, because we've been doing that, and to just break it down.
Do you feel like you've seen improvement with the students in that area, having spent some focused time on it? Or?
Yeah, I think they need to be, like, reminded to, like, slow themselves down. Because they, again, like, now are, like, reading problems, and they're like, I don't even know where to begin. And you're like, okay, like, what if we just wanted to, like, set up a diagram? And they're like, oh, I know where to begin now. And so I think they're kind of starting to get that way.
That's great to hear, for sure.
I think even in here they mentioned that if you were giving a big chunk of text for students to read, asking a question in the middle of the text would help them, you know, maybe pause and either reflect on what they've read so far, or break it up in such a way that they felt like they could process things better. And so I think, you know, even that process, or even giving them some cues of, okay, what's the big idea? What's the question being asked? And giving students a pause for reflection of how to unpack that problem is helpful. But even when you refer to, you know, making a choice between reading the textbook and watching the videos, I feel like I've attended sessions, some research sessions, where they've even said asking questions in the middle of a video and forcing students to pause and answer them increases the comprehension of that material, even in video form. So
one of the, like, TBL learning community things this semester, someone was talking about how in Canvas there is a way to embed that into videos and have it, like, be a part of the evaluation or something, I think.
Yes,
There's a bunch of other websites that do that as well.
Yes, and I haven't explored that yet, and I keep thinking I need to do that.
Like, there's some websites where you can just upload your video, and then it has tools to just go through, and it will pause the video, and you have to answer a question before you continue or whatever.
Probably like those annoying university trainings you have to do.
As long as it's not an hour and a half long.
True.
I had something.
I'm sorry.
No, you're fine. What were we talking about?
I was reading some slides, like, this weekend, and there was, like, questions in the middle, and that definitely, I think, it was, like, helping me actually, like, connect, because it was like, the slides were about something new, and it was like connecting it to old material.
Mm-hmm.
And, yeah.
Mm-hmm.
Because it did maybe just like slow down and be like, oh,
Yeah.
okay, this actually isn't like that new stuff.
Don't try to just skim through and get all the way
Mhm.
through it, which is what I might do or what my students might do, but to actually just say, no, our goal is to learn.
Mhm.
So,
I remember what I was going to say. I think that like with a lot of what people are saying, like it really focuses on how do you approach these problems or how do you read, which is a completely separate skill from actually solving the problems or actually the content itself. And so it's very easy to, I think many people whenever they're teaching math do this, like focus on the content itself and not take time to teach those skills of
Yes.
actually reading a textbook or approaching a problem or something like that. And like you were saying with the pathways, like having a dedicated time to both cover some of the how do you actually read problems as well as setting expectations for the course is really good at the beginning, and then also like saying slowing down and not just looking at the problems, but how do you approach problems. Like those are two different skills.
Yes. Yes.
I think it's important, like when you're doing examples, to sort of run through what's going on in your head as you're, you know, showing the students. Like, you know, you see that long calculus problem, and you read all this, and really there's no numbers here, there's no information, so this is just sort of fluff, you know, and sort of teaching them how to wade through the muck and get to what you really need to know to solve the problem.
Especially in like Calc 2 when you do series. You know, like I know how to do this series because I've done this so many times, but even just like doing one at first and okay, this didn't help us. What now? Showing them like the way you think would probably help.
Modeling thought.
Yeah.
This is kind of relevant to reading too, but I'm just wondering how much time do you spend teaching students notation and how to write math too? Because sometimes, you know, they can't write clearly. It's no wonder they have a hard time understanding what they're reading. You know, grading. I was doing some grading today, so.
So near and dear to you.
Yeah.
Especially with online homework.
Yeah.
You know, like you can't, I mean, with so many students, it's hard to, you have to do online homework, but then you're not seeing them, they're not writing it up. They're just, you know, scribbling all over their paper as they go, and then that's it.
What are some ways that you guys think things like that, as far as the metacognitive level or modeling yourself, problem solving, or even the teaching, okay, this is how we write, this is how we read, etc. I feel like one of the barriers, at least that I've seen for implementation, a lot of those things is time, right? Like that's a wonderful thing about, say, the pathways is that you get some dedicated time for that. But if you're in, say, a Calc 2 class, it's really, really tricky to justify spending time on those types of things. Although arguably you get a better result. It's not going to be a hard sell for me, but it's going to be a hard sell for a lot of people. So I didn't know if you guys have things that you've tried that are just little things that are easily implemented here or there. Even I love the idea of talking through a problem because that's very fluidly implemented in terms of talking through your own process. But yeah, do you guys have any other thoughts for how, within time constraints, how you can sneak some of those things in?
I know people, oh, go ahead.
I mean, I just, like, especially with, like, notation, like, people take the integral or take the derivative, but, like, forget to then, like, drop the signs. And just, I don't know, like, at least on the quizzes, like, I would start to get, like, very, like, harsh, like, taking multiple points off and just being like, this is being unclear. You know, you could have just done everything wrong, you know, like, that would make more sense in my mind. And then, and, like, seeing them kind of get mad, but just being like, this is, you know, like, you see me do it on the board. I explain my step that, like, now these signs go away because we did the thing.
Yes.
We took the square root, or, you know, like, we no longer need the sign. And
Yes. So communicating that this is a strong priority.
Yeah, and maybe allocating some points to when
Yeah.
you're grading to notation.
Yeah, so I know there's the rubric's like very strict.
Okay.
And now maybe
Yeah,
for
no.
calc.
Okay.
I don't know. Is it for
I didn't
quizzes?
feel
For
that
calc,
way
it's
about Calc
like-
3 anyway.
What is it like?
I know, like,
zero
so,
to
like,
five?
on, like, I know, like, on exams, like, it's pretty, like,
On
laid
exams,
out.
it's pretty fixed.
And, yeah, usually I would just be, like, okay, whatever, like, points they're, like, allocated for, like, finding the right answer, like, I always feel like I can redistribute those to, like, notation.
Yeah.
Like, if their notation's, like, just terrible to read through, and, you know, yeah, just even, you know, like, before, like, exams, especially, like, on the big calcs, you can say, like, no one's spending that much time, you know, reading your problem. If they do, they're going to get mad and then find things they don't like about it.
Yep.
I don't know. I usually tell them that, like, if I'm happy reading your work because it's all nicely presented and your notation's really nice, like, you know, like, I'm probably going to be, like, less mad if something's wrong on it.
True. Another thing, which isn't as applicable to a large class, but in a small class, I've never done this myself, but I've heard of people doing like homework presentations where they have to, I mean, I've never done it, so I don't know if they have, I had to do it as a student, I had to write on the board for Calc 3. We had to go through homework problems, and then but I think I heard of another person saying, okay, you have to have it prepared so you can put it on the board, like on a projector, and like, and then one thing they talked about as a class every day, it wasn't just the math, it was how is this written?
Yeah.
I think this was particularly an intro to proofs course that I'm thinking of that this person did, but I think you could do that for a small section of calculus or something as well.
My first thoughts whenever you said like, what are your thoughts whenever if someone said to you like, oh, there's not enough time? My first thought is suck it up and make some time because like it's part of the class and it's something that would be helpful. But second thoughts, not as sassy, would be sometimes you can really develop certain ideas or certain projects that do both go over some of the content as well as like teaching a process of how to approach something that kind of fluidly, especially if it's towards the beginning of a semester, that you can kind of fluidly set expectations, learn a bit of content, and teach thought process all at the same time. And those are sometimes difficult to develop, but even ordering of ideas. So like if I need to look at particular problems today over a quiz bank, then I would say, okay, maybe this is the sort of thing that I'd like to look at first so that I can model connections as we go through different things to kind of build up concepts as we go. Not so much talking about the particular problem itself, but concepts around the problems and tying those into them. And another thought that I had was if you can teach students to be a little bit more self-sufficient or think about what they're doing, then you can give them a little bit more to do, say, oh, actually look at this problem at home because I don't have enough time to look at this, but if I prepared you in the right way, then you should be able to do it. Which that's hard, especially on a general education type of class, to set those types of expectations. But a lot of times students will rise to that kind of challenge if it's not too much. If it's too much, especially towards the beginning, a lot of people just give up. But yeah.
Okay.
I liked what you said about when you, even if you're just, going through example problems in a recitation, you can be very intentional about how those are chosen and pointing out common themes or similarities between what you're doing. And that really ties into the rule versus example learning. So at the end of the book for people who weren't able to look at it, so basically they talk about how sort of lower level learners tend to focus too much on examples, and they'll learn that particular example independently from other things. They'll learn that example, just that little example. Whereas rural learners will go through an example and learn the principles behind the example. And specifically the idea of, what about this? What rules are going on? How do those rules apply in other situations? Now I see another problem and I have a context to put it in, as opposed to just knowing how specific examples work. So they were talking about how you can help example learners be better at becoming rule learners and extracting underlying principles. And it was basically exactly what you were saying, Joel, in the sense of it says example learners may improve at extracting underlying rules when they are asked to compare two different examples rather than focus on studying one example at a time. Likewise, they are more likely to discover the common solution to disparate problems if they first have to compare the problems and try to figure out the underlying similarities. So, I don't know, I just thought that really struck me when I saw it, because I thought, oh, we focus a lot on examples, for instance, within the current quiz structure, and I think this is something that could help people interact with that more productively. But I don't know if you guys had any other thoughts on this. There's sometimes questions are so different, but I mean, they're usually all within the same 3 sections of materials. So there are some underlying similarities, rules, principles, even on, seemingly disparate problems.
I think some students at least do a pretty good job of noticing that, because like students will ask, oh, can we do any of like this one, or this one? Because if I know how to do
They're
this
all
one, then
sort
I
of
know
the
how to do
same.
this other one as well.
That's awesome. And also, so it's not that they don't bash examples in the book, but they really try to point out this idea of example learning versus rule learning. But examples are super, super important within a math class, and I think they have a slightly different role than the authors, understand within the scope of this. So I was wondering if we could maybe talk a little bit about what role do examples play in a math class, and when you have students like Lee was saying, where like I learned through examples, what are they, what are they really saying, and how can we help them, and how do all those things play?
Can I say something kind of like related to your previous question about what's
Please
something you do? So one thing that I really like to do is like, when you go through like an example and then you have everyone do just something that's like a related example, but it's different. And when they get stuck, you kind of are like, okay, we have this other example. It's still like on the board. What kind of step was I doing? And can you perform a similar step, to what you want to do? And that's how I've kind of gotten students that are like, just like, enjoy seeing examples to kind of be able to extract, okay, maybe this is kind of more of a process, or this is like the kind of thing that I should be looking for.
Yes.
It's like, okay, on this one we added 7 to get x by itself. Now what do you have to do? And they're like, oh, subtract 6. And you're like, yeah, see, it's like, then they can have like, okay,
yes.
I'm performing an algebra, on it, or, I'm performing algebra on the equation.
And they're seeing those commonalities, even if, they're not exactly the same.
And so I think sometimes that's good when they, they have an example worked out solution, but they're trying a new one on their own. And I think kind of being able to like move from one example to another kind of helps them. Not just like compare to and say, what are the similarities, what are the differences, but
They can't talk about the structure itself. They need to talk about it in the context of an example.
But I think sometimes that's like easier for them because like if they don't know about the abstract, what they're doing.
Do you find that they do like try it on their own without looking at the board first?
No, this is like
that's what I'm wondering, if they're like, okay, they did this first, or not, I did this first, you did this first, and then do you know what I mean? Like if they're just like,
I think maybe they'll try it. They'll be like, oh, that was easy, I got, and then they're like, oh wait, no, like that was so
okay. I'm just wondering.
It's usually not like those types of problems. Like I'll say like for like, like in calc for like differentiating like with 2 variables. They'll be like, okay, what did we do first? Okay.
Gotcha.
I've told my calc 3 students this semester, like, you need to have examples that show you that things don't work out all the time. Like, absolute value of x. It's continuous, but it's not differentiable. And I said, okay, so remember that example. And then I showed them an example in recitation, similar to what we put on the exam, where it's the limit, it converges to the same limit along any straight path. But then it converges to something else if you go along a curve. and and they dealt with this on the exam. Didn't do so well, but yeah, but I think examples do another thing, and that's like show you why stuff's not
Yes.
true.
Yeah.
I mean, that's a big deal.
Yes. Counter examples. Sort of building up your arsenal of.
Have you seen the done the activity where say I've got a rule for numbers, and I'll give you an example of something that matches this. 2, 4, 6. Right? I want you to give me some examples of things that and I'll tell you whether it will match my rule or not. So they give you examples of different things, and I want you to try and get what it is. And so people will constantly be like, okay, well, blah blah blah, and it'll usually be they'll give things that they think match the rule, and it won't be. Like the rule in this case is just that they're increasing. But people always give 3 even numbers or different things like that. And say, okay, they all must be even. No, that's not the rule. Because you can't build a rule or build an understanding of something if you just have examples of what it is. You need counter examples as well. It's a fun one. It's off topic. What you said reminded me of it.
Related. So one of the things related to structure building too was the idea of learners separating the so-called wheat from the chaff. So being able to look at a problem. This doesn't have to be a written word problem. It could be any type of problem, and figure out what is the important information and what is not important there, and how structure builders do a better job with that. They're able to see, okay, high structure builders, what's important, how does it fit together, and low structure builders sometimes give things that are of low importance a more central position in the problem. Where they place them, they get thrown off on that one, like, no, that's not the important thing going on here. And I was wondering, just a lot of us have calculus or pre-calculus, and what areas do you see this confusion most, or where are some specific topics where you see students have a really hard time figuring out what's important, what's not, and sorting through that initial, chunk of information?
The exact thing that we're doing right now in Calc 2, it comes to mind, sequences and series, is like, we've already on the TRETs and IRETs so far done this exact thing, and been like, here's this really complicated sequence or series. Tell me about the sequence. Which, if they're paying attention, it's not a hard question. But if they're not paying attention, then it's like, oh, I'm supposed to find the 100th partial sum of this thing. That's ridiculous. But So I thought that was a nice way of motivating people to be a bit more discriminating.
Yeah, just to kind of bounce off O'Neill's, like, when they see something that's completely unfamiliar, like, all of a sudden when you start changing bounds, in 3 dimensions in Calc 3, like, it's just something they're, like, they've kind of maybe done, like, some polar stuff, which is, like, fine, but just kind of this whole, like, we're just going to give you this set of bounds that you want to integrate this space over, like, just change it to some other coordinate system.
Mm-hmm.
And just because I think it's like they don't even know where to begin, and that's when they just start, kind of like throwing the kitchen sink at the problem and just saying, like, what maybe could I do? They're like, maybe I could just try to brute force this. And you're just like,
But I mean, the other thing that we've been trying to convince them of for more than 2 months at this point is draw a picture, or in calculus you should draw a picture, and that's how you do that problem too.
It is.
I also think a lot of people have trouble if there's any related concept between things. They think they're the same thing. Like, if any two things you complete the square with, they must be talking about the same thing. And so I'm going to try and do the same thing with it.
It's a word problem. It must be related, right?
Yeah. Or like
optimization.
Yeah. You were talking about
I'm
problem
doing the
number.
same thing.
You were talking about problem number 2 on the last calculus.
Yeah.
Right. It involved, the first part was say, draw the level curves of this, which it has a graph there. So almost everyone tried to graph the domain of this 2-valued function because, like, a lot of the things that we did in this last stuff was graph the domain of a 2-valued function. So they see a graph and they're like, okay, yeah, I know that's a graph. I know what to do with it. Although it's asking it completely because they're two related things. And so in their mind, they've categorized this is the
Pictures
thing.
mean define it.
Pictures means do this thing, or this technique means I'm doing this particular thing. Yeah, and I think maybe that has to do with a misunderstanding of what's a technique and what's a tool rather than what's a concept.
And I think there you get that idea of that's from a few chapters ago of the varied practice too, right? And students have to have enough practice applying things in different contexts to be able to understand when it applies and when it doesn't apply, and not just want to, those two things are similar, they must be the same thing, but being able to discern.
I think maybe at the same time, like giving them time to actually talk about or think about what's going on rather than just working out the problems.
Yes.
Because you could say, oh yeah, here's a bunch of different examples and so on, but you also need the time to then compare those different examples maybe.
100%. 100%.
And I think that fits along nicely with what is in the previous section about dynamic testing in the sense of, giving students the opportunity to, whether we give it to them in class or they do it outside of class, is saying, okay, so here's a problem you can work on. Can you do it? If you can't do it, then that's an area you need to grow in. And here are some things that you can do to help. And then give them another problem. Can I do this? And just that way of whether we do it for them in class in terms of triggering, here's a quick little assessment. This is not something that's going in the grade. Maybe your effort will go in the grade book, but just giving them that time and space to say, can I do this? Oh, I don't understand this, and then being able to build on those skills.
Well, I've never, okay, so it's maybe a stupid question, but on the dynamic testing topic, isn't that kind of like the idea behind Alex? I have never TA'd for one of those courses, but.
I would guess so, although I think there's some AI built in so that
exactly.
It kind of hones in on what they're able to do and what they aren't able to do, and then yes, you're right, set up some sort of modules that they can work through to then learn those skills. I haven't worked with them either, but that's what I gathered from them.
I have no idea how good it is, but it seems like someone considered implementing such a thing for some level of mathematics.
Yeah.
The computers are stealing our jobs.
No.
Well, as long as they keep doing a bad job, then okay.
That's what I would love to do is program a program to teach using like dynamical things there, but it's hard, right?
Yeah, that dynamic testing, it's hard to know how to. I mean, we integrate it in the classroom when we can, and when you can sort of narrate or help students know that's what you're doing too, that can be helpful. Even though we think, a lot of times we think, they should already know that if they're given this example and they can't do it, then, that's a point of weakness. You should work on that. Right? But sometimes they need that more explicitly. But one thing, sort of two different things there. One thing, sort of helping students see the value of that outside of the classroom too, of essentially self-testing themselves and realizing that that shows areas that need to be worked on. And I think many of them do get this, right? And you see this a lot with how students work through, we've talked about this before, practice exams, right? Some of them do it well, some of them don't. Some of them work through the practice exams looking at the solution, right? Or looking at the solution very quickly. Some of them look at it more as a, oh, I tried this problem, I got stuck here, I need to work on that thing, I'll work on it, then I'll come back. So we see some students doing it productively, some not doing it productively. But I think that's an area for quite a bit of improvement in terms of what students are doing outside of class as well. And then what that was sort of transitioning into it here, they mentioned this, which is on a slightly different track. So they talked about the idea of viewing scores, these ideas of intelligence as either being fixed or something that's dynamic, and encouraging students to not see a test score as a reflection of their intelligence, and seeing it rather as you are on a journey, and this was one static snapshot of your journey, but because you bombed this calculus test, it doesn't mean, you know, you're not an intelligent person or that you're not capable of getting here in math. That's...
I don't know if I've mentioned this before, but I was talking to someone about teaching this summer, and he said he had like a 100, 200 person lecture, and they had their first test, and he called into his office every single person that got below 50%. Just like emailed them and said, hey, can you come see me? And then they were like, oh my gosh, like, what does he want? Like, and they come in, and he just like, I just wanted to check in and see how, like, I saw you didn't do well in the test. Like, let's talk about like how you studied and blah blah blah. And every single one of those people did better. Did more than 50%, and some of them were like at 80% on the second test. So I think, like, you know, it's hard, but like individual conversations can help, because then they know, like, I mean, you're talking about intelligence. It's like, okay, you failed this test. It doesn't mean you're stupid. It just means like maybe you need to work on how you're studying, learning. Yeah, I thought that was really cool, and I don't know, that's one case, right? But
well, and I think that goes back to number 8 also. You know, it says what you tell yourself about your ability plays a part in shaping the ways you learn and perform.
yeah,
And it's not only that, but I mean, we get little pieces of data here and there that say, oh, you can or can't do this thing. And so if an instructor then says the test didn't go well, but that doesn't mean that you're stupid, you know. I think that could do a lot for,
yeah,
you know, moving students forward. But yeah, it's a matter of. So, going back to your comment, is that a suck it up and do it, or is that, you know?
To on which comment, on talking
Number
to students
8,
or
yeah,
to
well, no,
telling students to suck it up?
no, I'm
Sorry.
no, I mean so I'm thinking, what if I have a third of my class who they perform poorly on an exam, and I'm thinking of anywhere from 5 minutes to possibly 30 minutes for students to want to go through different parts of the exam, and I'm just like, you know, that seems like a valuable thing to do, but at the same time, I'm just like,
I don't think it was going through the exam though. I think it was just like.
But I could see how those conversations could lead to that.
Yeah.
You know, like,
Right.
I don't understand. That's not why we're here. We're not here to talk about that, you know.
Yeah.
It's just here to give me I'm going to give you a pep talk. Now go look at the solutions, you know. But, you know, but where do you draw that line?
Yeah.
In terms of, okay, I'm giving you 5 minutes.
Yes.
Versus.
I think that's on a completely different level, because it's just, that's on a like forming relationships with students level, which is another thing, like that's super helpful. It's a difference between The first one, as far as time, was like, oh, we don't have enough time in structured class time because there's a finite amount of it.
Right.
The other one is, it's going to be a lot of work for me that I have
Right.
to do now.
Right. Right.
Yeah. Yeah, I think, I always think students, at least having the illusion that we care for them is pretty good. No.
And I do.
Yeah.
I do, but
I never said that
I
we
also
didn't,
think-
but
I'm just like,
Yeah, you get that impression.
yeah,
You might care for them, and they don't think you.
exactly.
That's true.
Right.
That happens.
Impression is
Yeah,
Yeah,
important.
but it's also like it's important to also care for yourself and like realize
Yes,
that, like,
exactly.
you cannot
Yeah.
be here for 60 hours every single week.
Yes.
Even if that is going to make all of your students learn like the most excellent. Like it's just
it's not
yeah.
reasonable. It's not
Which is
helpful.
why, like, I think like doing something to address people's feelings would be good, but it doesn't have to take that format, right?
Right.
Yeah.
Right.
Like it could be something as much as I always like doing small like opportunity because some people get themselves down because specifically of grades, so having a chance to kind of either make up points or show that they can learn this better is super helpful for a lot of students. That's how I've addressed that in the past. Just do like a small quiz that might be a few extra points, or if they can do like if they can show me correct solutions to something. That's
That
in
was
different
this
forms
weekend.
depending
I
on
gave
how
them
many
like
people.
a special worksheet,
Mhm.
and I said it can either make up one online homework like assignment or one in-class assignment. And some of them are like, "Oh my gosh, because I forgot we had online homework, and now my grades like not looking so hot," and they're really excited about it.
Yeah.
I'm like, okay, this is great. This because I wanted you to all do this. And
Mhm.
now you're all like super motivated to get it all like 100%.
Right.
Yeah.
So don't tell them that you're going to drop homeworks in advance. Do
I think so.
convert it into
Yeah.
drop opportunities during the
Drop
semester.
opportunities.
Yeah.
Because
if
then
they-
then they're like, if they want to be like, oh, that that homework or that assignment like went really bad. This is something that's like related to stuff they did. It's just like a little bit more advanced because we're a little bit farther down the road.
Yeah.
So they're still having to show like proficiency in it.
Yeah.
That's stuff that's very beneficial for them to spend time on. Like it's really,
It's better for them to see it at the end of the course as a benevolent like day that you've had to say, oh, I'm going to drop one of these rather than and give you an opportunity to make it up rather than a calculated thing that you've done at the very beginning of the semester. That's kind of, I don't know.
Maybe
think
Well,
like,
also I think it's just like different because if you don't tell them you're like I'm not going to drop anything.
Yeah.
Then they're like, oh, no slacking off for us.
Yeah.
Got it.
Yeah.
But like if you tell them those opportunities, like
Yeah.
I just like learned that this computer science class I'm in has 2 dropped homeworks.
Oh, nice.
And which is like, yeah, I'm like, no, but I'm like, I tried like so hard, like up until this point. Like I would have just slacked off so much
Yeah.
more if like I knew that. And
Well, sometimes, like, if they have 2 dropped homeworks, they don't, and they've done fine, they just don't do the last 2.
Yep.
And then it's, yeah, that happened in my class last semester. And my advisor was teaching it, he didn't like that, so this semester it's not on the syllabus, we can do them all.
Syllabus,
Yep, he was not happy.
you could plan on 2 dropped homeworks, tell them about 1 dropped homework, and reserve 1 for an incentive. Because then you're still getting out in front of people going like, I want makeups, I want makeups, I want makeups, by having 1 dropped homework that they know about.
those are all really interesting. And
Yeah.
it's interesting philosophically too, because everybody's going to take a slightly different take. Definitely no right or wrong, but it's interesting to think of the different aspects.
like when Nate Benjamin, he taught last summer, and his syllabus was like really just like complicated. It was like you get points for doing this and points for doing that. Like
Were there like 2 kinds of points?
yeah, well it was like you get like half points for every office hour you show up to.
Oh wow.
Oh wow!
Like yeah, and it was like for full hours. So if you came like half and half, and like it
Oh
was
my
like,
gosh!
How many people come to this?
It
do you
was
keep
like,
track of
I know,
that?
so like he somehow kept track of all of this. But I remember he was like, oh, can you read the syllabus? And I'm like, I'm just sitting here trying to figure out how I can do the least amount of work, like, and still get the
It
most.
becomes
amount.
a-
Like, I'm trying to like gain your syllabus in your class, like.
Well, that's an optimization problem.
I
That's really interesting.
No, it was like everything had a point related to it. It was like asking a question was like a quarter of a point. It was like like it was like
very intense.
Yeah, and it was like he's like somehow got it all to just add up to like 100 points.
Wow.
Which
I mean, you should see it. It was like it's crazy.
I should see it.
Did he make it with a linear program or something?
I don't know how he did it. I just
Nate did not make it with one.
well, yeah, that's also
He would
probably
not have
true.
wanted to.
Okay. He took that class.
That's interesting.
I don't think I would do well teaching that way.
I couldn't keep. And then everything becomes. I mean, this is my personal opinion. Again, other opinions.
The
But then
motivation.
all behaviors become so point driven, right? And like, don't we want students to be learning driven? But I understand incentives, offering incentives for students to do things that are going to be helpful that they might not do otherwise, right? And then they realize the benefit.
And then it's like, oh, I did really bad on my exam, but like I can, like make that up, like by going to like so many office hours or asking so many questions in class.
Right.
And so there was like things like that.
Motivation.
Yeah, it's a hard question of asking, are the points there to be a motivating factor? Which, yes, but also are the points there to also reflect evolution of learning across the course?
Yes.
My analysis course,
I also hate points.
our homeworks, he graded them, but he never, he looked at them and stuff, but he never gave us grades. We created a homework portfolio. So we got like feedback and stuff, but we never saw scores on them. And I remember being like, I don't know how I'm doing. And he was like, you're fine. Don't worry, Lynn. By the end of the course, I was like, okay, I'm fine. And I ended up being fine, and everyone was fine. But I don't think you could do that with calculus, but...
You gotta know your audience.
Yeah, it was like there was like 8 of us in the course. Like,
I was teaching
If
math
I was-
160, and they were all about, I just gotta get an A. I gotta get in med school.
yeah,
Was what I dealt with.
and that's hard when they need a grade to get into med school
Yeah.
or whatever they're doing. Really, you should learn calculus to get into med school. You should take a calculus.
That's what we
course.
have.
Isn't calculus on the MCAT?
I have no idea.
I've never taken the MCAT.
That'd be awful.
Like teaching, especially a general education course, right? We have to remember it's not just teaching content, but also assigning a grade for them to get a degree, which is frustrating.
Right,
Well, like,
that's
how
what
do you
I'm
balance
saying.
those?
Like,
Yeah.
how do you balance what's important when the grade for them is important for a specific reason? You know?
Easy. You just either give everyone A's or give everyone zeros.
I had to write a paper about this in Calc 1. But what was more important, the grade or learning?
Of course, the right answer is learning.
I was about to
But
say, there is a-
everyone's
But
also
everybody's in their mind
Yes.
wants the grade. I mean, I did as an undergrad for sure.
Yeah, he had us read an article and write a response on it. As a high schooler, I hadn't really thought about it a lot, so.
Was it worth points?
Yeah, I think so. I think so. But, he didn't. Our Calc homework was like a point 8 problem set,
What's the whole colleges that don't have grade systems, and everyone gets an evaluation at the end, and somehow that gets converted into a GPA.
Nice.
Yes, yeah, you.
Isn't MIT like that?
It's Brown. It's like that.
Brown does that?
Brown
I think
does
MIT.
that.
I thought MIT did it for like their first year or something.
Maybe that's true. Yeah. Maybe my cousin does one.
Right, like some European schools like that. I was in college. I was talking to someone from Italy, and they said no graded stuff. You just take a test at the end, which is a little intimidating. But
Yeah, it's just kind of I think it's more of everything's pass, no pass.
Yeah.
You either got the credits or you didn't get the credits.
Mhm.
Well, it's 3 to 5.
Thanks for joining us.
Good job,
2 weeks, chapter 7. You want to do that?
Teamwork.
How many chapters are there?
8, and then there are a lot of notes, footnote
Gotcha.
or not footnotes, but endnotes.
Mm.
So
So we actually have a chance of getting through it.
yeah, we have.
Oh, yeah.
So yeah, we have 2 chapters remaining, and chapter 8 is actually a big summary. So
hey,
thanks for the questions.
Did you